lesson, we will learn to determine if a relationship is proportional. Prior to Christmas break, we were solving proportions, and we were trying to calculate the unit rate or the concept of proportionality from tables and graphs, and we were also writing equations that represented proportional relationships. And so we're going to use that knowledge to now determine if a relationship is proportional. If a relationship is proportional, we can calculate the unit rate, which is the constant of proportionality, and we can write an equation to represent the relationship. If it's not proportional, then I cannot find the constant of proportionality, and I cannot write a proportional equation. So let's first focus on proportional graphs. In order for a graph to be proportional, it has to start at the origin, which is 0, 0 on the coordinate plane. It also must be one straight continuous line. And that means it doesn't have any curves or zigzags. So now let's take a look at the examples. The directions say circle all of the graphs that represent proportional relationships. Explain why the other graphs are not proportional. Example 1 is a proportional relationship. I know that it's proportional because it meets my two requirements. It starts down here at the origin, and it is one straight continuous line. Example 2, however, is not proportional. It's not proportional because it does not start at the origin. Example 3, even though it starts at the origin, it's not proportional because it is not one straight continuous line. It's increasing, then it's constant, and then it starts to increase again. So I did not have one straight continuous line, therefore it's not proportional. So let's put not continuous. Example 4. Example 4 is proportional. It meets my two requirements. It's at the origin, and it's one straight continuous line. What I want you to do now is try examples 5, 6, 7, and 8. In examples 5, 6, 7, and 8, the only one that is a proportional relationship is example 6. Example 5 is not proportional because it's not at the origin, nor is it a straight continuous line. So not origin, not continuous. Example 7, even though it starts at the origin, it has curves. Same thing with example 8, it has curves. Therefore, it is not proportional. Now let's look at proportional equations. When you take higher level math, you'll learn all these different types of graphs. We have some graphs that are linear functions. We have what are called quadratic functions, and a couple other functions that you'll learn about in further math classes. But in 7th grade math, we're just going to focus on proportional equations. And so in order for an equation to represent a proportional relationship, it has to be in the form y equals k times x, where k is the unit rate. I can't have anything extra, just the unit rate in front of x. Remember, k represents that unit rate or constant of proportionality. And so directions. It says put a star next to all of the equations that represent proportional relationships. Then identify the constant of proportionality for each proportional equation. So let's take a look at question number 1. Example 1 is proportional because it just has y equals 12 times x, where 12 is the unit rate. So put a star. So I would say k equals 12. Example 2 is not a proportional relationship. In addition to having y equals 17x, it has this extra plus 12. Therefore, it is not proportional. Question number 3. Even though it has 9x, I have this extra 2 minus. Therefore, it is not a proportional relationship. What I want you to do now is try to look at examples 4, 5, 6, 7, 8, and 9, and identify the equations that are proportional. All right, so you should have found that example 4, example 6, and example 8 were proportional. In example 4, the unit rate is -7. In example 8, even though it's a fraction, that's still K. It's in front of X. I would say K is 3/5. And in example 6, even though I have a decimal, that's still my unit rate, 0.4. It's okay to have fractions and decimals as your constant of proportionality. Now let's look at 5, 7, and 9. The parts of those equations that made them not proportional. The exponent, because there's a 2 on top of X, that is not proportional. I can't have an exponent on the variable. In example 7, I'm adding 12 again. And in example 9, 1 is over X. X cannot be on the denominator of your fraction. Therefore, it is not a proportional relationship. Let's take a look at tables. In order for tables to be proportional, if on my table I have an X value of 0, then the matching value must also be 0 for Y. And then when I simplify my ratios by doing Y over X, it has to be equivalent every time. I have to have a constant of proportionality, the same unit rate. If my table does not meet those two requirements, then it is not proportional. So let's take a look at example 1. When I look at this table, it does not have an X value of 0, so I don't have to look at the first requirement. I just need to make sure that every time I simplify Y over X, I get the same number. So let's try this out. So each time Y over X, and then I need to simplify. So for my first one, I'm going to do it off to the side to have a little more space. I have 6 divided by 2. And when I do 6 divided by 2, I get 3. For my next value, I have 15 over 4. When I do 15 divided by 4, I do not get 3. I get 3.75. And so I can stop right there. I see that I don't have the same unit rate, so therefore it is not proportional. Let's take a look at the second one. In example 2, again, I'm going to do Y divided by X. This table meets the first requirement. When X is 0, Y is also 0. So now I need to do Y divided by X. So I'm going to do 10 divided by 2. And when I simplify that, I get 5. But for my next one, 19 divided by 3 does not give us 5. 19 divided by 3 gives us 6.3 repeating. Therefore, this one is also not proportional. Notice that I didn't do 0 divided by 0 because that's not possible. It's undefined, so I just have to test the other values. Now let's take a look at example 3. Again, let's do Y divided by X, and then simplify. It meets the first requirement. I have 0, 0. So let's move to the next one. 8 over 2. 8 divided by 2 is 4. My next one, I have 16 and 4. 16 divided by 4 is also 4. So because this table has 0, 0, and it has the same constant of proportionality, I would say yes, it is proportional, and the unit rate or the constant of proportionality is 4. Now let's try this next table. This time I have a vertical table. I can just look at this one and tell it's not proportional. I don't even have to calculate the unit rate because when X is 0, Y is 5, and it should have been 0, 0. Therefore, it is not proportionate. And our last value, our last example, example 5. I don't have an X value of 0, so I just need to move to the next requirement and do Y divided by X. And I made it so big so that this time I could have some room to simplify. So this time when I do 9 over 27, that's not going to be a whole number. That's going to be a fraction because the numerator is smaller than the denominator. Both numbers are divisible by 9, and so I get 1/3. The next one, I have 8 over 24. Both numbers can be divided by 8, so I simplify and get 1/3. For my next values, I have y over x, 7 over 21. Both numbers can be divided by 7 when I simplify my fraction, so I get 1/3. Two more values. I have 6 over 18. Both numbers can be divided by 6, so I get 1/3. And my last value, I got to test them all to make sure I always get the same number. I have 5 over 15. They both divide by 5. And as you can see, I also get 1/3. So because I got the same unit rate every time, yes, it is proportional, and the unit rate is 1/3. In this lesson, we learned how to determine if a relationship was proportional from a table, graph, and equation.